Hello everyone and welcome back to the channel. Today we are going to be reviewing the IDAS NBZ II Nebula Booster Filter. This filter was sent to us from Astroworld Telescopes.com and we're going to be putting it up against the Optolong Extreme F2 version. We're going to see how well they compete against each other in a fast scope. So let's jump right on into PixInsight. All right, so here we are inside of PixInsight, and let's just get right into this NBZ II filter review. So let's get this data sheet opened up. And this is the transmission rate, what we're looking at here. Let's get, here we go. This is the 03 side. So this filter is designed to work on fast scopes and slow scopes. So basically the whole F scale. And what this is showing you here is that we were using a 2.2, F2.2. So somewhere in this green line, the transmission rate, which is for 03, this particular filter is, the bandpass is at 7 nanometers. So it's a pretty, it's not very tight, but it's not wide open. So it's a pretty good middle of the road filter here. But what I want to point out is that for this particular test and this scope, we were somewhere around the 92-95% transmission rate. So it's a really good transmission rate that the 03 will come through. And then we go down here to the H alpha. The H alpha has a tighter band pass at 3 nanometers. So it's really, really tight. And we're somewhere in the 2.2 to 2.4 area. So between this dark blue and green, so there's the dark blue and there's the green. So we're about 95, 96, maybe even 97% at a pass-through rate. So that's telling me that if we're looking at the sky, 95% of the H alpha signal is getting let through to the camera sensor. So this is a really good filter. There is the data sheet for the IDAS NBZ II filter. All right. And again, that was a 10 nanometer pass for the HA and an 8 nanometer band pass for the 03. Now let's look at the Optolong L-Extreme F2 version. And what we have here in the 03, we have a 7 nanometer band pass. And it is roughly somewhere in the lines of 90%. We're in the F2 zone. So we're in the orange zone here. So actually just shy of 90, so about 89, 88, 89%-ish pass-through rate for the 03. And the H alpha is a 3 nanometer band pass, excuse me. So it's a tighter band pass. And it is, again, we are in the F2 to F2.2 range. So the orange range here, the orange line. And it's above 90. It's about 93, call it 94%, maybe 95%. So it's a pretty good transmission rate as well. All right, so that is the specs for the Optolong L-Extreme filter. And what I did was I just went out and since this is a RASA, I'm using the Celestron 11-inch RASA to do these tests. And I don't have a filter, an automatic filter wheel. I have a filter drawer, so I have to change out filters as I go. It's a little different than using like the red cat with the filter wheel. But for this particular test, I just used a filter drawer, and then I did all the tests, the 10-second test, the 30-second test, 120 and 180. Then I realized that I'll just do those. I just do those per filter. So I did all of the NBZ filters first for the quick 10, 30, 60, 120, 180 second, and then I moved over, changed out the filter, and did the the L-Extreme, the Extreme Optolong F2 filter, and did those, and then just compared them as such through here. So this over here, what you're looking at now, is the CAF. We looked at the star CAF because it's a very bright star. Normally you wouldn't be imaging this star, but this particular star happens to be what I call a filter killer, or maker or breaker, because you can really tell right away whether or not it's going to control the star halos or not. So this is a 10-second image on the NBZ filter. There's no calibration frames existed for this. All I did was just a little bit of automatic a SETI Astro dynamic background extraction, or ABDE. And this is the Optolong side. So over here on the left is the IDAS NBZ. The right hand side is the Optolong. Now right away I can tell about the gradient. Sorry about that. The gradient here that I've got going on. All right. So right away I can tell that I've got a gradient going on between the two filters. The NBZ filter is lighter in color, and the Optolong F2 filter is darker, and that's because of the tighter bandpass. But with the 10-second exposure time, I don't see a big difference here. The stars look the same, roughly. All of them look pretty good and tight. And again, with the 10-second image, not going to get much there anyway. But there's not that big a difference between the two filters at the 10-second range. So let's look at the 30-second range here. So there's a 30-second image of the NBZ filter on the left, and let's do a 30-second of the Optolong F2 on the right. Again, it's the one on the left, the IDAS, is a little brighter, which is to be expected because of the band pass is a lot wider. It's not as tight as the Optolong F2, and the stars still look pretty good and the same. It's kind of hard to determine which ones are better or worse at this particular point, but I think they're looking kind of equal at the moment, in my opinion. I think they're fairly even. Just maybe the Optolong F2 version shows a little bit more stars coming through in this area over here, but I still think they're pretty evenly matched at this point. But when we move to the 60-second, this is the IDAS on the left, and this is the Optolong on the right. Now, just looking at it, it looks like the same as the 30-second. But if you start to look really close, right around in here on the F2 here, you can start to see a halo forming. And let's just get this zoomed in the same. There is no halo on the IDAS filter, but there is clearly a halo starting to form on the Optolong F2 filter. So at this point, now is when you have to start worrying about the halo on your stars. But again, we're looking at a very bright star. Normally you wouldn't just image this particular star. So the halo starts at 60-second exposures with the Optolong. Let's move over to the 120 on the IDAS on the left. And the 120 Optolong on the right, and it's clearly visible, a huge halo. It's really visible here on the Optolong, and there is no halo present at all on the IDAS filter. So I have to give it to IDAS at this point. The halo control is really good, really good. The stars still look very nice. They all look really decent and about the same roundness. Actually, the IDAS filter is starting to look a little bit better as far as keeping the stars a little tighter, not so wonky looking. So definitely IDAS so far has better looking stars at 120 and no halo. So let's go to the 180. And here we are at 182nd exposure. And again, it's more pronounced now than it was before. But you can clearly see on the Optolong F2, there's a big halo around the star here, around CAF, and the IDAS has no halo, has really good halo control. Very pleased with that. The stars still look really good on both filters. And I would say at this point, there's no halo on the IDAS. There may be a hint of a halo starting, but there's clearly a halo around the Optolong F2 one. So that's at the 180. So at this point, both filters perform really well. Both filters look really good. You just have to be concerned a little bit with some haloing going on at the 120 or more exposure time with the F2 version. So after I did the stars, I wanted to go and take a look at an object, and what I did was I went and looked at I believe this is the Pac-Man. So I did a 10-second image. Again, this is with the Celestron 11-inch RASA. This is a 10-second image with the IDAS NBZ filter. And as you can see, there's no, there was no haloing of the stars, but the stars still look nice and round, even all the way into the most outer reaches of the corners here. Stars look pretty good. And that's not a bad 10-second image for the Pac-Man. All right, so that's the IDAS version. And let's do a 10-second image for the Optolong F2 version. And you can see, again, it's just the gradient is just a little darker for the Optolong, of course, because it's a tighter bandpass. But I think they're doing the same. I mean, it's really hard to tell the difference in the quality of this 10-second image between the two. But again, it's only a 10-second image. But there's probably a little bit more of detail. Excuse me, it looks like it's transmitted through on the Optolong side, but at 10 seconds, it's really no big difference. There's not much to that. So let's go over to 182nd. A lot more signal coming through at 180 seconds. It looks really good. The IDAS controls any of the halos that are going on these stars. There are no halos like that were pronounced in the CAF version of the F2. So there's really nice looking stars in this one. A really good looking image overall for 180 seconds. That's the IDAS. Now let's do the 182nd Optolong filter. And it's looking good overall. It's got a really nice gradient. Even capture a little satellite going through there. The stars look really nice. It transmitted some really good detail. Let's pull these two up and let's see which one has the better detail for the inner part of the nebula here. They look pretty the same. I mean, this looks really nice and good for 180 seconds. Stars look really good. And the same on the IDAS filter. Looks really good. There's some, it's maybe just a contrast. Maybe the contrast is it's a little darker on the F2 side, but of course it's a tighter band pass. I can't really see that big a difference in the way it looks. It's just preference at this point. I think they're kind of equal here. The stars don't have there's no haloing issue going on the F2 side here. I don't see any major halos. And let's go and look at the stars into the corners like we did the other one. Still looking pretty good there. Stars are looking good all throughout the image. Some stacking artifacts there. I'm not sure what that is. Well, it's not a stacking artifact because this is just one image. Maybe some hot pixels going on there. All right, well, there's the 180 for the both. I think they're looking pretty good. Maybe there's a little bit of color difference, but again, I think it's pretty even at this point. I'm kind of leaning towards the F2, only because it's a tighter. It looks like it's got a better contrasted image, but the signal looks the same to me. I can't really tell. So right now, I think it's just a preference. But both images look really good. All right, so let's look at the 5-minute image. This is a 5-minute image of the Pac-Man Nebula, and it looks really good. All the stars look really good here. That's really nice. There's no calibration frames here. This is one straight 5-minute image. And all I did was the SETI Astro ABDE, automatic background extraction, I believe is what it's called. It looks really good. No complaints with that one. And let's look at the Optolong 5-minute. Let's get this blown up a little bit. It looks good too. It looks maybe... No, okay, all right. I was going to say, looks like maybe there's some halos going on there, but that's it looks really good. Stars look really good. I think they're pretty even at the moment. Let's get this one zoomed in to this one. See if we can't find some issues here. Let's see here. All right. So on the right is the F2 Optolong, and on the left is the IDAS. Now, this little piece of the nebula here looks like there's a little hook that comes out on this side, and it looks a little bit, maybe it's just my eye, but the IDAS looks a little bit more detailed and less fuzzy than the Optolong. But again, it's probably just the way I'm looking at it. I don't see like there's any big difference in the two. It's really hard to tell at this point if there's one has a better image over the other. They both look really amazing for 5 minutes. I think still at this point it's a preference. Let me know what you think down in the comments as far as what you think you see at the moment. Which one has the better detail or contrast at a 5-minute image? And that's both the same zoom detail there. They look pretty even. The stars look pretty even. The color on the stars look pretty even as well. Let's see if I can find that one little star here. Let's see where to go. There it is right there. All right, so let's get this the same zoomed in level. They look pretty the same. I mean, that they both, actually the color looks a little better. I think the star color looks better. To me, the star color looks better for the IDAS versus the Optolong. But again, I think that's just probably just preference at this point. All right, so there's those 5-minute images. Let you see those one last time. It's really difficult to really make a choice on which way you go here. You can't go wrong either way. The F2 here actually has a tighter bandpass, so it may give you a little bit more leeway in a light polluted scenario. But so far, they're looking pretty good. Now here's an image. This is right at 7 hours of exposure time, and I used my ZWO 130 APO, and it's a f7.7. This is the NBZ filter for the M82 Cigar Galaxy and the M81 Bode's Nebula or Galaxy. Let's get it zoomed in here so you can kind of see what's going on here. I think it did a pretty decent job here with the colors. There's all I did with this was, of course, there's calibration frames. I did the bias, flats, and the darks. And I did SETI Astros, ABDE, SETI Astros, statistical stretch, one correct only on blur exterminator, and then noise exterminator. One iteration of just the defaults. That's all I did with this one. I think it turned out pretty good. This is a slow scope compared to the RASA f2.2. I think it turned out pretty well for not doing much with it. And I think it did nice. Stars look really good. There's no issues with halos. And these were 10-minute images. These were 10-minute exposures. So there's no blown out stars. Maybe if you zoom in, you might start to see some halo in there. But that, again, that can be corrected with the blur exterminator. And these are 10-minute long images. And it might just be me just thinking it's there. But I think this image turned out really nice for a slow scope. All right, so there's an example of 7 hours of exposure time on a f7.7 scope with the NBZ filter. And this is NGC 1931. And this is basically 2 hours of exposures. And these were 10-minute exposures as well with the RASA. And all this was just a few calibration frames, the same SETI Astro automatic background extraction, statistical stretch, and then correct only blur exterminator and noise exterminator. And then I did star exterminator. So as you can see here, the stars look pretty decent. They're, you know, there's not much, there's not a whole lot of things that I did to this photo. This is pretty much almost a raw photo, other than one iteration of correct only for blur exterminators. So that's pretty decent. The color came out pretty good. There's no halos that are sticking out that are going, oh my gosh, we got to fix these. They don't look too bad. So here is, oh, I'm sorry. This is with just the image, the plain image, automatic background extraction. And this is the same image with a blur exterminator and noise exterminator applied to it. You can tell a huge difference in the way that the stars look. That's not bad. For 2 hours, that's not bad. This is the IDAS filter. Not bad at all. The color came out really nice. And again, this is a really bright star here. And you can tell that there's no, the halo is not pronounced as it was with the F2 version, because now you can go ahead and see the actual, looks like the rays, it looks like a rays from the sun here. So there's no big halos that are calling out saying, hey, we have an issue here. Some of these will have what look like diffraction spikes, but that's probably because the way I have the cables rounded off the camera and the power cord on the RASA. I probably need to do a little bit better job of routing the cords right to either make the diffraction spikes or make them more pronounced or not. But then I did a starless version, and I think the starless version came out pretty well. This is the first time I've ever imaged this particular image, and I think it came out pretty awesome. For 2 hours, doing for the IDAS NBZ filter, 2 hours in the RASA, and just did some one version of noise exterminator, a blur exterminator correct only, and then a star exterminator, remove the stars. I think it came out pretty spiffy here. This looks really nice, really, really neat. Overall, very pleased with the IDAS filter at this point. I think that turned out really well. And like I say, we didn't do anything to the colors. We just processed it as is. I would love to go back and get 10 more hours, maybe 20 hours on this particular one to really make this pop out. But there you have it. I'll see you in just a moment for final thoughts. Okay, all right, here we are for final thoughts. So at this point, it's really a preference, I think, on what filter you would like to use, whether it be the IDAS NBZ II filter or the Optolong L-Extreme F2 filter. I will tell you that having imaged quite a bit with both of these filters, they're both great filters. There is some issues with the Optolong F2 filter. I love Optolong. I have a whole fleet of almost every single Optolong filter that they make. I love Optolong. However, when using it in the RASA, it has an issue with the halos. And now this F2 version was well, first of all, this filter is specifically designed for fast systems. The IDAS NBZ II filter, this filter here was designed for all systems, slow systems, fast systems, everything basically. It's basically a one-stop filter. You can you can just buy this filter and it'll work with every scope that you got. If you buy this filter, it will work with the fast systems. I've tried it and I've had 50-50 in slow scopes. It's not designed for slow scopes, it's designed for fast scopes. So with that being said, I think that if I had no filters at all, and I wanted to buy one filter that I could use for my one-shot color images that would cover me for a diverse set of scopes, I would choose the IDAS NBZ II filter, solely because it has pretty good transmission lines along fast scopes and slow scopes. And in this video, you saw examples of what a slow scope and a fast scope would look like beyond a 180-second image. So with that being said, I want to say thank you to Dan over at AstroworldTelescopes.com for sending us this filter for review. I really appreciate it. And if you have any telescope needs or any questions, please visit AstroworldTelescopes.com or Astroworld TV and tune in every Wednesday and Friday at 8 p.m. and join the chat, join the Discord, and if they can't answer your questions, someone on the Discord or the chat will be able to answer your questions. Thanks again for tuning in, and as always, clear skies.